Hi guys, this is review number 9, complex fractions. I think I got my sound worked out, so the videos should not be as echoey as they were last week. So this lesson is complex fractions. This is when we have a fraction within a fraction. In pre-calculus and calculus, we would like you to solve these by multiplying by the LCD. So we're going to start by looking at all of the denominators. So in the top part of the complex fraction, look at the denominators, and you have an x and a 1, because this is subtract 3 over 1. So the LCD of those two fractions will be x. In the bottom part of the complex fraction, look at the denominators again, and you'll see that the LCD is x subtract 1. So what we're going to do is multiply the entire complex fraction by x times x subtract 1 over x times x subtract 1. And the goal is to get all of these denominators to cancel out. So we take this and we multiply it to each part of the complex fraction because there's a subtraction there. Because there's a subtraction in the bottom, same thing, we'll multiply this to each part of the complex fraction. And then we see what we have left. So looking at 2 over x, the x is going to cancel with this x, leaving me x subtract 1. So now I have 2 times x subtract 1. The 1 won't cancel with any of it. So that gives me a subtract 3, and we have the entire thing left, x times x subtract 1. Then what we're going to do is same thing in the bottom. So this x times x subtract 1 gets multiplied to the 1. 1 over 1, nothing cancels with that denominator. So we're left with the entire thing times 1, which is x times x subtract 1. X times x subtract 1 is going to multiply to the second fraction. And here I can even just cancel it out so you can see. So this x minus 1 and this x minus 1 will cancel, leaving me with negative 1 times x, which is simply negative x. Now from here, in the numerator you could factor out an x minus 1, and in the denominator you could factor out an x, so that's one strategy. The other strategy is just to use distributive property, so 2x subtract 2 and negative 3x squared plus 3x is going to be over x times x is x squared, subtract x, subtract x. You can see I combined like terms. I had the negative 3x, I put the 2x plus 3x equals 5x together, and the negative 2, so subtract 2 over x squared minus 2x. From there, I'm going to jump up here, and we are going to factor that negative out of the numerator since I don't want a to be negative. So now we get 3x squared. If I factor the negative out, then it's subtract 5x. Factor the negative out, so it's plus 2 over x times x subtract 2. Looking at the numerator, we want to make sure that this isn't going to factor with an x subtract 2 so that it cancels. So what we're going to do is factor to see if anything will cancel with the denominator. If not, then we're done. So I'm going to do guess and check. Guess and check, you do first times first equals first. So 3x times x is 3x squared. Now you have to guess for the 2 times 1. Do I put the 2 here or do I put the 2 here? So that's why it's called guess and check. You may put it in the wrong place and it won't work, and then you have to erase and try it again. Guess and check. All right, so I think I'm going to need to put the 2 here and the 1 here. And the reason why is negative 3x and negative 2x is negative 5x. And then negative 2 times negative 1 is positive 2. So that's my guess and check. Now, unfortunately, nothing cancels. And because nothing cancels, then I just call it good and I'm completely done. So this would be my solution. Let's look at example 1b, and I had to rewrite it because I ran out of room on that other page. It's hard to write small with this whiteboard pen thing. All right, so looking at this, we're going to use the pre-calc method by starting to look for the LCD. I have an X, so you write it down. I have an X plus 1, so you write it down. Here you have an X plus 1, but you already have the X plus 1, so you don't have to write it down again. So you only need one of them. The goal is to multiply this whole thing by X times X plus 1 over X times X plus 1. This is really the number 1 because of the subtraction in the top between the two fractions. You multiply both parts. And then in the bottom, you'll just multiply the one fraction by X times X plus 1. Looking in the numerator, the X is going to cancel with this X, leaving me 1 times X plus 1, which is just X plus 1. The X plus 1 will cancel with the X plus 1, leaving me negative 1 times X, which is negative X. In the denominator, the X plus 1 will cross cancel with the X plus 1 up top, leaving me 1 times X, which gives me just X in the bottom. The X and the negative X will cancel, and my final answer is 1 over X. Example 2a, we'll start by finding the LCD. U is in the bottom. I'll write it down. 6, I need a 6. I'll write it down. U, I already have a U, so my LCD is 6U. I multiply the entire thing by 6U over 6U. Because of the subtraction in the bottom, this 6U is going to multiply to both fractions. Let's see what we have left. This U will cross cancel with this U, giving me 6 times 6. You always multiply what's left. Over 6 will cancel with the 6, leaving me U times U, which is U squared. And then you've got a subtraction. Be really, really careful with those subtractions. So you need the subtraction. The U is going to cancel with the U, and then you multiply 12 times 6, which is negative 72. So subtract 72. Example 2b, we have 16 on the bottom. And be careful because this is really 12 over 1. So the LCD, you have a 16, and a 1. So the LCD is 16. So you're going to take the fraction and multiply the whole thing by 16 over 16. In the top part of the complex fraction, both of these 16s will cancel, and then you just write down what's left. So those canceled with the 16, and you have 9 plus X subtract 1. In the denominator, nothing's going to cancel with the 1, so you're going to need to take 12. So 9 plus X subtract 1 divided by 192 is going to equal X plus 8 over 192. Another way to do this same problem is if you notice that you have common denominators in the top. So what you could do is you could combine that top fraction as 9 subtract 1 is 8. So X plus 8 over the common denominator of 16 over 12 over 1. And then you would just proceed in the same fashion, multiplying the top and bottom by 16 over 16. Example 3a, the very first thing I did was take x squared subtract 4 and factored it. So it factored as a difference of two squares, x plus 2, x minus 2. From there, in your Cornell, I want you to find the LCD, and you could push pause and see if you can figure out the LCD. So looking at all of the denominators, I see that I have an x plus 2, I write it down. I have an x minus 2, I write it down. And in the bottom, this x plus 2 is going to match, so I don't need to write it down again. It will cancel. And keep in mind that the negative 3 and the negative 1 are all over 1. So I'm going to multiply the whole fraction by x plus 2, x minus 2. In the top part of the complex fraction, the x plus 2's are going to cancel, and the x minus 2 is going to cancel with both of these. That leaves me just with x squared. The subtract 3, which I really do like to put plus and negative often just to make sure I don't lose the sign. Nothing cancels with the denominator. So you're going to have a negative 3 and you're going to multiply it by both of those. And you can multiply those back together as x squared subtract 4 just to make it a little quicker. In the denominator, the x plus 2 will cancel with the x plus 2, leaving me x subtract 3 times x subtract 2. And we're going to FOIL that in a moment. The negative, the 1 doesn't cancel with anything, so you have subtract, and you can write it as x squared subtract 4 again. And make sure you use parentheses there. It's subtract the whole thing. All right, so we're going to take a moment and simplify. In the numerator, I have an x squared subtract 3x squared, because I'm going to distribute, plus 12. In the denominator, I'm going to do first, outer, inner, last, and it's going to give me x squared. Negative 2x and negative 3x is negative 5x, and last times last is plus 6. Subtract x squared plus 4 when I distribute that negative through the parentheses. That's the biggest mistake I see, is that negative only gets distributed through the first number. So be careful with that. Okay, I'm going to combine my terms right now. So let me come back up here. I have x squared minus 3x squared, which is subtract 2x squared. And I have a plus 12. In the denominator, I have the x squared and the negative x squared cancel. So that's negative 5x. And I have a plus 10. Now, typically, we don't like the a term being negative, so I'm going to go ahead and factor that out in the numerator. If I factor out a negative 2, then I end up with x squared plus 1. In the denominator, if I factor out a negative 5, then I end up with x subtract 2. The negative and the negative are going to cancel. You can leave your answer like that, or sometimes they'll multiply it back through. But example 3b, let's take the top part of the complex fraction and let's combine those two fractions into one fraction. So I have an x squared as the common denominator, and in the top, 1x plus 1x is 2x, and negative 3 plus negative 6 is negative 9. That's going to be over x over, and then I have x subtract 5 plus x over x subtract 6. We're going to multiply the whole fraction by the LCD of, you need the x squared, you need the x subtract 5, and you need the x subtract 6. Same thing on the bottom, x squared times x subtract 5 times x subtract 6. Looking at the numerator, or not the numerator, but the top part of the complex fraction, you can see that the x squared is going to cancel with this x squared, leaving me 2x subtract 9, x subtract 5, and x subtract 6. And this will be all multiplication. So 2x subtract 9, x subtract 5, and x subtract 6. In the bottom, we're going to take the x minus 5. It's going to cancel with this x minus 5, leaving me x times x squared, which is x cubed. And then you still have the x subtract 6. Plus, and then you're going to cancel the x minus 6 with the x minus 6, leaving you with x times x squared, which is x cubed again. And you still have the x minus 5. From here, we can multiply out the whole numerator but I'm okay if you just want to leave it in factored form. So I'm just going to leave it. In the bottom, if you want to factor out the x cubed, you can. And so when you factor out the x cubed, you're going to be left with x subtract 6 plus x subtract 5. You can simplify that denominator as x cubed times 1x plus 1x is 2x, subtract 11. And so if you want to leave your fraction in factored form, here's the numerator and here's the denominator. Thank you.